Thank you, Helen. Brilliant. Thank you, Helen, for staying on the recording as people come in. Hey, Scotty, how are you, mate?
Hey, I'm good, thanks, Jason. Very good, thanks.
What's it been like? I've just come back from leave and just seeing all these new faces and all these new things happening. So what's been happening in your world?
In my world, there's been lots of customer activity going on. There's been quite a lot of tool development, quite a lot of new exciting things people are wanting to play with in OCI. So that's fun. Keeps me busy.
Keeps you busy and keeps the rest of us busy as well. So very cool to see people coming online. We'll just wait a couple more minutes as people start joining. But thanks, Scotty, for offering your time and talking about the topic today. So it'll be interesting in terms of where we go with the topic, because it is something that I see that it is something that we are seeing more and more use cases around files being transferred and just keeping that security element in place. So actually, looking at the time and looking at how people are going, let's actually kick off. So welcome everyone today to Franco. We do actually have Thursday with Franco online, but today is just going to be myself and Scotti Fletcher. So today, Scotti, what are we going to be talking about? Because I suppose one of the things that you've been building out is definitely in that security space and creating a really effective way of managing files and security. So talk us through what you got.
Yeah, sure. Thanks everybody for joining. Give me 1 second and I will share my screen and we can walk through some slides. Okay.
Cool, that looks good.
Yeah, it looks good. Awesome. Brilliant. Yeah, so today we're going to talk about how you would handle uploaded files in the cloud. And this is something that when I joined Oracle, I went, cool, I wanted to learn some new things. And this was one of the things that I built using OCI native services and how you can actually achieve virus scanning in the cloud. But before we jump into how we do it, an interesting statistic. So this year in January was released that in 2021, cloud apps, cloud providers was responsible for 66% of all malware downloads. So traditionally, malware was delivered via email. It was delivered via malicious websites. That has become more difficult, primarily because we now have better controls around, okay, saying this domain's trusted or this domain's not trusted. And so browsers, endpoint detect and response is really good at saying, actually, I don't trust this, so I'm not going to allow you to download it. Why people have moved to cloud apps, cloud providers, you know, you've got OneDrive, you've got Google Drive, you've got a whole range of others, is largely because those domains are trusted. And so it becomes more difficult to say, well, is this a domain that I like or don't like? You can't make a deterministic decision because the domain itself is trusted. And that issue also then extends into cloud-based applications, right? So if I'm running an application, someone uploads some malware, if my domain's not flagged, end users are likely to be able to download it from my site. So something to be aware of, that it is actually increasing, and it's become more complex depending on the types of.
Yeah, you go for it.
Oh, yep, sorry. Yeah, so it's become more complex as you move into a cloud environment, and I'm going to talk about that next. So your traditional application development. So I've tried to keep it really simple here. So if you have an on-prem data center, or maybe it's even your home workstation, it's sitting in front of you, right? You've got the operating system, you've got the physical device itself, you've got the storage, you run your applications on your operating system. So in this diagram, that's what I've illustrated. And traditional, virtual machines running VMware, running on physical servers in your environment. The interesting thing here is that your virus scanning software operates at the operating system level. So you install the tool on the operating system where your applications reside. And the virus scanner does a couple of different things depending on which flavor you go for. Some of them will scan files on the file system. Some of them will scan files like they'll look at the behavior of the files when they operate. So they run them in a sandbox on your machine. Say, okay, are they interacting with your registry, making system calls that we don't like, and therefore we'll flag it as potentially malicious. But the key thing to remember here is that this is a full stack. So you're actually managing the infrastructure, you have access to the storage because that's what the virus scanner needs, and you're also running your applications on that infrastructure. When we move to the cloud, and so cloud has a whole range of different services, right? So you've still got your traditional infrastructure as a service, so compute hosts and OCI, but you also have other services as well. So serverless functions typically run, APIs running through an API gateway. You might have integrations. You might want to talk a little bit about that, Jason. So you have data coming into your environment. Where do you store it? If you're still using IaaS, great, that's cool, but you're probably not leveraging the cloud in the best way possible, as in you're storing files on a server, you have to replicate those for backup. There's a whole range of things that make storing files the same way you did in your traditional data center model, this one here, less appealing when you move to the cloud. So you start thinking about, well, where do you store those files? But the catch with all of this is that unlike your traditional data center, when you move to the cloud, some services you actually only control, as it says here, what's in the green box. So things like serverless functions, you don't have access to the operating system, and you don't have access to the underlying storage. So you can't install a virus scanner in your serverless function, as an example. And this is where it becomes a bit of a problem, because often you have scanning requirements. I think being a security tester for a number of years, working as a consultant, you often see requirements say, hey, we need to scan uploaded files from users, and that's protecting us as an organization, saying we're not going to accept malware into our trusted environment if it's potentially malicious. People often also say we want to check those downloaded files. So we need to make sure that before we serve content to users, that we're not sending them something that's potentially malicious. We also want to check the files before use. So say we do take a file, or it comes in somewhere, it gets uploaded somewhere. Before we use it, we should probably also check that it isn't malicious, and that protects both things that are running in our environment and also to anyone else or any other system that may actually run that content. And we should check all files. It's no point in just saying, hey, we only want to check files in this specific location. So say FTP uploaded files. What about files that are uploaded via your web server? So all of these types of things are generally seen as requirements, but how do you actually do it when you possibly can't install a virus scanner? And I should also highlight that OWASP, so the Open Web Application Security Project, is a really great source of material. They have a page specifically on how to deal with file uploads. I'm only specifically talking about one of, I think, about 15 recommendations that they recommend for if you're going to handle files and accept file upload, what you should actually do to ensure the security of those files. Any questions before I move on? Anything you want to add, Jason?
Yeah, nothing from what I could see in the chat, or but it definitely, especially with the types of files that we're actually doing, because I can think of numerous different types of things that I can see that we're sort of doing, even just with object storage as an example, like database uploads and import exports, doing things with OCI data flow, with Spark applications, getting data sets and those kind of things. And even some of the things that we're doing with the demos, we've been treating the bucket as a public website and exposing that as a file system of sorts. So each one of those things, whether it's actually internal or external, then it's how do you actually still maintain that level of security across those files, whether you mean to, maliciously, or whether you do that naively.
Yeah, that's a really good point. And you bring me to my next topic, which is where would you store those files? And object storage is probably one of the best places to store unstructured data. In OCI, we do have like block storage, and we've got network storage. There's a whole range of different storage options, but one of the most common places people will put files is in buckets. And so the bucket is a great place to store unstructured data. It gives you different archiving tiers, so you can say, actually, let's move it to a cheaper storage tier after so many days. You can life cycle it. You can do a whole range of cool things with it. You can replicate that data easily between regions. So object storage is probably the most likely place where if you take an uploaded file from a user from a website or from an FTP server or from another system, as you mentioned, around the data integrations, the bucket is the place where it's going to end up. And so here is the solution architecture, and this is what I'll be demoing to you next about actually how do we do this. And so on the left, we've got users. For all intents and purposes, I'm using a website here, but the mechanism on the left could be FTP or any other source of your data that is being uploaded or transferred into a bucket. I've got two buckets, bucket 1 and bucket 2, really great names, but they could be any bucket. Those buckets, essentially when objects are created, they have an event that gets fired. And so when you create a bucket, there's a tick box I'll show you that shows you how to emit object events. And so when something gets created in a bucket, it fires an event that says object created. That event rule then fires my function, which I've called scan upload, and I'll show you that too. Scan upload, it's not actually shown in this diagram, but goes out through the internet gateway to, it could be anything that can check. And in this case, I'll talk a little bit about this later, actually checks the file hash. So the file, the MD5 file hash that gets created that aligns to the object in the bucket, we then check against a database that says, okay, hey, what do you think about this file hash, which returns a result to the scan upload function, and then it can do a range of different things. It can delete the file, it can leave the file in the bucket, or it can move it to a quarantine bucket. And also as a result, we log the output. So we push those log results into logging, OCI logging, which I've called scan results. I use a service connector to then move those scan results into a bucket to then import them into logging analytics, because I really like the logging analytics capability. And I like the fact that I can actually visualize my data, and I'll be showing you that as well. Any questions, anything you want to add on the architecture, Jason?
No, that looks all pretty good. I can see there's many other ways that we can use those events, because not just through object storage, but many other types of services that we're pulling through that we could actually apply a very similar approach. So it's highly flexible in terms of extensible for other services as well.
Mm-hmm.
Cool. Let's see it.
Perfect.
Let's see it. Show me something.
I'll show you something. Okay, I'm just waiting for my page to load. Give me 1 second. So, okay, we'll start with the bucket end of things, and I'll walk everyone through what I've done here. There's only a few things you actually need to configure to make this work. So we've got 3 buckets here, as in the diagram: bucket 1, bucket 2, the quarantine bucket. This fire scan results is the scan results on the previous in the diagram. That's where the logs are actually stored that I then use to pull into logging analytics. There is another way to do it. But if, for example, you wanted to store those results for a long period of time, or you wanted to maybe ingest them into your scene, then doing it via a bucket is one way you can do it, which is why it's here. So we've got a bucket. I've got some files in here. So I will also mention that I am going to be uploading malware, and I should feel like I need to give everyone the warning that says, if you're not sure how to handle malware, don't. Or you need to at least understand that you shouldn't be executing this in a trusted environment. So in this case, they're all zip files, so they're non-executable, which is why I'm choosing to use zip files. So if I upload, and you can get these all from GitHub, actually, if you wanted. And so this is where I've got these malware samples from. I'm going to choose to upload them to a bucket. And this will take just a quick second. Once they've all uploaded, I will walk you through how I've gone about setting up the other components. Would help if I had a faster internet connection, I think.
That's okay.
What happens when you live in the country? Okay, so if they all finished. Yep, they all, one's still going.
So these are you actually just grab them from a public GitHub repo. So why? So in terms of actually this process, right? Why are people putting these things out there?
So there's a range of reasons. Malware researchers typically will release malware samples. It helps researchers understand how the malware works. It helps people understand what signatures and detections. In this case, I'm using it once again as basically to trigger a signature, to be able to say, hey, okay, I know that this is malicious. So yeah, look, there's a whole range of different things. I guess the flip side of that point is that yes, people could take that information and possibly try and unleash it, but this is the whole point. If the information's free, hopefully people that are going to do something about it will do the right thing, create signatures, fix antivirus products, all those kind of stuff. Yeah. But yes, there are a whole bunch of different repos on GitHub that host this content that you can obtain. Once again, do so with caution. Okay, so I've uploaded my objects into a bucket. We'll jump to functions actually. So here's my scan upload function. When you create a function, an application, and then an application contains lots of functions. So I named my application virus scanner, and I've got a function here called scan upload. And I will quickly, where is, of course now I can't see it. Let me just 1 second, I'll find the code just to show everybody. There is actually code on GitHub, which I'll show you at the end, that shows how this works. Looks fairly complicated, but basically all it is doing, I'm importing the OCI SDK here, and then I'm essentially checking the file. So I'm taking the file and I'm sending some data off. I'm sending it out to the internet here with the file hash. I'm getting a response, and then I'm taking some action. So all my function actually does is when it receives an event, it takes the MD5 hash, sends it in this case to VirusTotal, but you could use anything here that has a list of known MD5 malware hashes, or you could use another hash. You just have to calculate it. And then I'm using it to take some action. So I've got quarantine it, delete the object. Down here, I'm doing some logging. So this is essentially how I create the log from my serverless function. So I've created it and I've uploaded it here. And you can see it's been running. You can see it's been running over here as well, which is all good. You can also see some errors here. So I should just mention, if you do see errors, probably the most common one is that the functions run out of memory. So you just give it some more memory and life's good. In my configuration, so I will change its API key as well. But basically, if you are to configure this, you go into configuration. In fact, I added it at the parent level. So you can apply configurations at the application level or the individual function level. So I've given it my API key here. I've said, don't scan my results bucket. Otherwise, it would scan every time a log was created for no reason. The name of the bucket where I want to put the file if it's quarantined. The delete threshold. So it's relevant to talk about this. So VirusTotal has, and I'm only using this as an example. I could have chosen any other option here. It has a whole range of scan engines. So what I'm saying here, if half of the scan engines say that this file is malicious, just delete it. Down here, I've said if one engine reports it as malicious, then I should quarantine it for further review. Basically, what do I want to do if there's an error? So if the function fails, do I want to quarantine the object and look at it later? Or do I want to delete the file? Or do I want to just let it pass? So you can configure that here as well. You'll see all of that in the code. The log ID, which I'll show you next as well. And that's essentially it as far as function configuration. If you're not familiar with serverless functions, just go and have a look. It's pretty straightforward. In fact, you can go here and get all the instructions under the getting started. I use the local setup, and it gives you all the instructions of what you need to do there.
So very much that the virus scanner is really that execution engine to both configure some of the rules, but then execute the scanning, I suppose, method detection bit off with the hash, and then come back with the result. So
yes,
it's nice that it's integrated with those events, so that you don't necessarily have to build a lot of the infrastructure around it. You just execute, go off. And maybe this is a good point of time, because Sean's actually asked a really interesting question with, and maybe you want to bring it up in the considerations bit around zero-day attacks and just if there was no signature in place around what you're detecting. So happy to answer here, or maybe at the end.
I will do it after the demo. It's a very good question, Sean, and I have a very possibly a good or differing opinion to some of the 0-day questions, and I have been asked it a lot, not just in the malware space, but in the app sec space as well. So look, I will answer that then. So if we move on just real quick, so when you create your function, you actually need to have your function, you need to authorize. Everything in OCI needs to be authorized to take actions. To do that with the function in this sense, I've created a dynamic group. I've called it virus scanner dynamic group, and you'll see why. I've basically said where the source is, sorry, the resource type is the function itself, and which compartment I want to run it in. So you could change compartment, you could run it at the tenancy level. Obviously, I've just chosen to run it at the compartment level for this demo. So I've created my dynamic group. I go to my policies, and I've created, I'll show you the other policy in a second, but in my virus scanning demo policy, I've allowed that dynamic group name here to manage objects. Yeah, so that's cool because I need to be able to move them and delete them. So I need that permission. I've said I want it to use log content. So that allows me to, when the function runs, push a log event to logging, which I think can important to a dashboard. The last two here are quite important. So because object storage is encrypted, the function service doesn't specifically have access to read objects in object storage. Even if you say, yes, it can manage objects, it actually can't decrypt them without being able to read the key. So in this case, I've chosen to use the Oracle managed key. If you were to use your own key, you could do that too. And you could lock that down even further and say only this specific key ID if you wanted. So these last two here allow the function to be able to read the actual object metadata like the MD5 hash. Once I've done that, basically, I've already uploaded the objects into the bucket, so we can see some here. The function has emitted some events, which is fine. Actually, I can show you that here, which is the event rule. If I go into my edit event rule, all I've done is gone event type object storage, the type of object event type that I would like, so object create. And then all I've done here is say, run a function in this compartment. That's my virus scanner application, and that's the function itself. And I've saved it. That's cool. If we look here in the last hour, we can see that it's actually run a few times. So all well and good, we know it's run, but what did it actually do? So in my function, I've got a log group, so virus scanning log group. In here, I have two logs. So I have scan results and I have function invocation logs. So my function invocation logs are what happens every time the function runs, an event will be created here. And also I can create my own logs. So you can see there's some standard ones in here, but if we look down here, we can see one here that says quarantining, a little support box out of the way. It says quarantining, and if we look at it, it'll say why. Where is it? Yep, quarantining this file, confidence 5 above quarantine threshold 1. So if you actually want to see what it's doing to make decisions, you can see here. So if we look down here as well, it's saying deleting file confidence 80 above threshold 50. So that was obviously the configuration items I set. So you can immediately see if it's working or not. If you see errors, you can look at the errors and understand what's going on. But essentially, this is the activity log for that function. And if I look at the other log group, which is scan results. So this is so here we go. Basically, this is what I import into logging analytics. So what was the action that was taken? What's the link to the file if I wanted to go and look at it more? What bucket was it in? What category? What the confidence level out of, like, what percentage of the engines told me it was malicious? File size, file type, hash, the message, the name of it, all those kinds of things. So positive signals, so the number of engines that said that it was malicious, the number that said that it wasn't, right? So this is quite interesting. If we look at this and go, well, 5 engines said yes and 56 said no. So there is an argument here that says if you're using a larger scan engine that has multiple engines plugged into it, you get better coverage, right? So if you were in the case that you had an A/B scanning product that was in this 1 in 56, you might have not picked it up. So just something to be aware of, and the ultimate result here, which is fail. Okay, that's great too. So we've seen it does some stuff, but actually if I want to see some insights and go, okay, well, what actually has happened over a period of time? I've created a wonderful dashboard here in logging analytics. And basically it's taken all of the information from that scan results log and I've made it into some pretty pictures. So basically over time, what's happened? So how many files passed, how many failed, saying that it's still collecting some data here for the ones that most recently got uploaded. What action was taken? Did we quarantine or did we delete the files? They're all zip files, I expect that. Also over here, what are the top threat names? So this would change depending on other malware or viruses that were potentially in object storage. Where are the malicious files? So where is, if you have lots of buckets, in which buckets do I need to go and look, and maybe perhaps investigate why we've got more in one bucket than another. And if I actually want to have a look at the detail, I can drill down here and say, okay, this file was quarantined. I can click this link and it will show me information about, if I go to that, it will actually just show me the information and which scan engine said it was potentially flagged as malicious. All right, anything we want to add or ask here, Jason?
No, that's pretty good, because I was going through the different logs, and so I can see the data shaping up, but until I actually saw it in log analytics here, so you actually get a bit of a high level view, but also the table that you got there gives us the detail that we need on a file by file basis. Then it really comes together at this point, where the log files, as well as even the function is very much the data pipeline of getting that executed and surfaced here. So no, this is very cool that you can see all this data all in one place. I'm looking at this also in this architecture there. Then the scan result and where those files are, they could be. It doesn't have to be from buckets, right? There's other places where it could come from.
Yeah, that's right. So you could extend it. And in fact, I have a where to from here slide, but yes, I've chosen the bucket as a central place where all my files will be stored, but you could extend that into other places as well. You might say, hey, if a file goes onto a file system, you could move it to a bucket to be scanned, for example, as one example. But once again, yeah, perhaps if you have different components in your environment, you might have a different solution for each. But this is how you would do it if you didn't have access to the underlying operating system to install a virus scanner.
Yep. Yep.
Awesome.
So,
oh, yep.
Oh, Chris is just saying thank you. He's got to drop onto another call. Sorry.
Okay.
That
All
easy.
good.
So yeah, where to from here?
Yeah, so I think probably spend a little bit, like a couple of minutes on explaining why I chose to do it the way that I did, and that'll lead into the question around 0 days. So often when we think about uploading files, we think about scanning files on a local file system. That's great because we control the data, we control where it lives, and that's primarily a data sovereignty concern. So if, for example, you are going to use a cloud-based scanning solution, do you really want to be sending data overseas? A lot of contracts say here in Australia that data must be stored and processed in Australia, but cloud platforms, as we all know, can operate globally. And so this is one of the things we need to consider. Local laws and regulations as well. So often documents, things may be sensitive. It's probably quite timely that, how we handle sensitive data is reviewed. And so do we want to be sending full files out to scan somewhere? Probably not. And so we need to consider, well, what information are we sending? The file hash doesn't contain PII, so that's fine. The third-party anti-malware risk. So if you are going to be installing AV solutions, and this comes from my days as a pen tester, there have been known instances where anti-malware, antivirus solutions are potentially exploitable themselves, and so do introduce some level of risk. But you also need to consider, well, are we going to do this in line, or are we going to do this out of band? So I've chosen to do this in an out of band manner, meaning that the file's uploaded and then I do post-processing on the file. Because if you do it in band, what if someone uploads a 5 GB file? Are they going to sit there and wait for half an hour? Probably not. That's a bad user experience. So I've chosen that as my method, which kind of also leads to performance and scalability. If you're doing it in band, then you need to be also thinking about, what if I get 5 files at a time and I'm running this in my own AV scanner on my local disk, or I'm using a service to do it, like what's going to happen if things going to time out, a file is potentially going to end up not being scanned. And then how do I then support that with my operating model? So are we going to tell users, hey, no, we can't upload that file? There might be some things where you don't control, like an FTP, for example, might be really hard to be able to actually inject it, scan it, and then reject it before you save it, if that makes sense. So if you're going to do it in the out of band way, how are you going to basically mean data integrity for things that might reference the file that potentially is malicious? So doing it with a function means I can call another function to be able to say, okay, update the database, send an email, notify an admin, whatever the workflow needs to be. It makes sense to do it from a serverless function. And that all kind of leads into the licensing and infrastructure costs. So you can, if you're going to run your own AV scanner, you have to provision it for your peak load. Also licensing costs, maintenance costs of the compute, and all of those things too. So those are the reasons why I chose to do it the way that I did.
And Paul's got an interesting question more so, and you don't necessarily, maybe we do take this offline if it is a bit sensitive, but he did ask about, are we looking to set up an antivirus as a service or something similar in different regions, and or providing different ways that we can actually communicate, advise around different threat and providing that advanced threat capability, right? So any thoughts or indications on that?
Yeah, look, I think that's an actually interesting topic. It's probably another Thursday with Franco all by itself. I do know that a number of some of our SaaS products have it built in, but as far as if you were doing it in your own environment, it's the shared responsibility model. So it would be nice for cloud providers to do it, but none of them do, right? So this is just a gap, but once again, it comes down to the shared responsibility model. We as Oracle secure our own cloud, and we do provide tools for customers to secure their own. I think that's where you're trying to go with it, Paul. But yeah, happy to have more of a discussion around what we can do if you have a customer in that space.
Cool, appreciate that. And I think what you demonstrated here is something that's actually very applicable to many different parts of the business. It's like you talked about, it's just even we're uploading files all over the place, doing file transfers into SaaS being as one example, or extracts out of SaaS being another. Doing things like with computer vision, with the OCI vision service, with uploading images all over the place around those kind of services from a machine learning and AI perspective. We're doing stuff around doing data exports from a database cloud, right? So doing DBCS cloud packages to export, import data in and out of autonomous database. So there's plenty of ways where I see that we're using files, and what you demonstrated today is something that from a security angle and to look at some of these risks are natively there because we are using these channels and these kind of services in such a way. So I appreciate your time.
Yeah, so I will answer Sean's question now, which was my next slide, which was where to from here. Yep. So I chose to go with a more constrained model to say, hey, I want to ensure that I'm ticking off all the boxes around PII and local laws and regulations. Not that I'm actually using this yet, but if I was to use it, I know that I'd at least be ticking off those things to show at least how, if you have those requirements and you were in that kind of edge use case, that you can still achieve it. But that raises the point, Sean, which is around if there's no specific malware signature yet, and how do we do with 0 days? And so one of the things you could do from taking my model, instead of calling a database with known malicious malware hashes, yes, that would mean that someone would have to have identified it, they'd have to fingerprint it, they'd have to create a hash, they'd have to upload it for you to be able to then leverage that information, which is what's happening here. You could extend the function, as I mentioned. You'd still have the option of installing a compute host or multiple compute hosts that can run as an antivirus scanning solution. And so you could stream the file from functions to that to get a response. That's one option. By doing that, depending on which antivirus, anti-malware engine you choose, some of them have what we call sandboxing features. And as I mentioned earlier, so sandboxing doesn't rely on a signature. There are AV scanning solutions that do, and 0 days very difficult to detect with those unless there's part of it that it detects. But as we saw in my scan results, you know, a hit rate of 5% still malicious, right? Or I know they were all malicious to start with, but a lot of them said that they weren't. So depending on how the scan engine is built and how it operates, how it's configured, will actually help determine on whether it's malicious or not. But the sandboxing feature basically says we take the malware, we unzip it, we untar it, whatever we need to do, we execute it in a secure environment, and then we look at the behavior of that environment when that malware is running, and that's what a sandbox does. So there is that, and usually that would help go beyond just a basic signature detection. Once again, it's not a foolproof solution, but it's still a control. And when we talk about handling files, there's all the others that I mentioned in OWASP that you'd also employ. So you're not just relying on scanning of the file, if that makes sense. Beyond that, yeah, zero days are an interesting one. Maybe we'll take that one for another topic, Jason.
Yeah, I think so. I think so. So you said you had a couple of references that you want to share at the end.
I do. So there is a blog article. I wrote this a few months ago that talks about everything that I've done. I reran my instructions yesterday and they work. So if you follow those instructions, you can also set this up for yourself. You can have a try in OCI and see how it works. You can play with it yourself. Once again, be careful with what you're doing with malware. I take no responsibility. Also the code for the function and also those dashboards. So here on GitHub, so the function itself, I think there's two other files. There's the dashboard configuration and there's also the log parser for my specific log format that I've chosen to use. That's all on GitHub that you can access as well, along with a bunch of other resources for all of the components that I've provisioned today.
Yeah, I think being mindful of just letting it out and just giving it a go. One that I think probably just reaching out to yourself or to the security infrastructure team locally here is probably a good step to make sure that we're looking at those kind of use cases in a, let's say, a responsible fashion, such that we are protecting ourselves not just by putting something like this in place, but also taking those considerations that you sort of made mention about as well, especially from that privacy perspective, and also making sure that we're spending the time and energy in the right way. So installing that kind of AV software takes a different route from some of the other techniques that you sort of made mention here today as well. So I appreciate the time.
Awesome. Does anyone have any questions?